If I had to start over and master Python from the basics to advanced in 2025, this is exactly how I'd do it. Hi everyone, and welcome to this step-by-step roadmap to learning Python. If you're new to programming or just starting with Python, you're in the right place. Python is one of the most popular and versatile programming languages out there, and today, I'll be guiding you through its core concepts, one step at a time. We're going to start with the absolute basics, so don't worry if you have no prior experience, as this is a beginner-friendly journey. If you're wondering where to begin, what topics to focus on, or how to structure your learning, this roadmap is for you. Before we dive in, let's talk a little about Python itself. Python is a high-level interpreted programming language. Now, what does that mean? Being interpreted means that Python code is executed line by an interpreter, rather than being compiled into machine code first. This makes Python easy to write, debug, and experiment with, especially for beginners. Python is also known for its simplicity and readability. Its syntax is straightforward and resembles plain English, which makes it an ideal choice if you're new to programming. But don't let its simplicity fool you. Python is incredibly powerful and is used for a wide range of applications, from web development and data analysis to machine learning and artificial intelligence. All right, now that you know why Python is such a great language to learn, it's time to take our first step in this roadmap: understanding the variables. Variables are where we'll start because they're the foundation of any program. Think of variables as containers that store data. They allow us to store and manipulate information, which is essential for building programs that actually do something useful. In this section of the roadmap, we'll look at what variables are, why they are so important in programming, how to create and use variables in Python, and finally the rules for naming variables correctly. We'll also take a quick look at the print statement, which is used to display or print information on the screen. Here you will print your very first Hello World program in Python. This is a handy tool you'll use constantly as you learn Python, especially to see the output of your code and debug issues. Now that we've covered variables, it's time to explore something even more foundational: the data types in Python. These are the core building blocks of any program, and mastering them is essential for every beginner. Think of data types as the DNA of your code. They define how information is stored and manipulated. Python offers a variety of data types, each with unique characteristics and specific use cases. Let's break them down into four main categories. First, we have the fundamental data types. These include integers, floats, booleans, and complex data types. They're the basics that form the foundation of Python programming. Then we have sequential data types. Here we have strings, bytes, byte arrays, and range data types. These data types let you work with sequences of elements, such as characters in a string or a range of numbers. Then we will learn about collection data types. This category includes lists, tuples, sets, frozen sets, and dictionary data types. These data types are designed to store and manipulate collections of data, whether it's a simple list of items, a set of unique values, or a dictionary with key value pairs. And at last, we'll see the none type. The none type represents the absence of a value. While it might seem straightforward, understanding how to handle none is crucial for writing clean, error-free code. By understanding these data types and their purposes, you'll build a strong foundation for writing efficient and effective Python programs. Now that we've learned about data types, let's talk about two essential techniques that go hand in hand: indexing and slicing. First up is indexing. So, what is indexing? Well, it's a way to access specific elements in your data, like getting a particular character from a string or an item from a list. Python makes this super easy. And once you understand how indexing works, you'll be able to manipulate elements in both sequential and collection data types with confidence. Once you've got indexing down, we'll move on to slicing. Slicing is a powerful way to extract specific portions of your sequences, like grabbing a substring or a subset of a list. It's like being able to zoom in and work with just the part of your data that you need. You'll also see how slicing can help you modify sequences to fit your program's requirements. After mastering these concepts, we'll dive into something equally important: typecasting. Typecasting is just a fancy term for converting one data type into another. It's a skill you'll use all the time in real-world programming because you'll often run into situations where data needs to be transformed to work correctly in your program. For example, you might need to turn a string into a number or a list into a tuple. Learning these techniques will be a game changer as you start building more complex Python programs. All right, now that we've covered the basics like variables, data types, and typecasting, it's time to move on to a very important topic: operators in Python. Operators are essentially symbols that perform specific actions on one or more pieces of data. They're like the tools in our programming toolbox, helping us manipulate data and control how our code behaves. In this section, we'll explore the 7 types of operators you'll come across in Python. For example, we'll start with arithmetic operators, which are used for things like addition, subtraction, and multiplication, basic calculations that you'll use all the time. Then we'll move on to assignment operators, which let us assign values to variables, like when you're setting up your data. After that, we'll dive into relational operators. These are super useful when you need to compare values, like checking if one number is greater than another, or if two variables are equal. Once we understand comparisons, we'll take a look at logical operators, which allow us to combine multiple conditions. This is essential for writing code that makes decisions based on several factors. We'll also cover bitwise operators. Now, these might sound a little advanced, but they're useful when working with binary data and can come in handy in specific scenarios. From there, we'll explore membership operators, which let you check if a value belongs to a list, a string, or any other collection. Lastly, we'll look at identity operators, which help you determine whether two objects are the same. By the end of this section, you'll have a solid understanding of how these operators work and how to use them effectively in your Python programs. This is a crucial step in your learning journey because mastering operators gives you the power to control and manipulate your code like a pro. Alright, now that we've got a good understanding of operators, it's time to move on to an incredibly important topic: flow control statements in Python. Flow control statements are the backbone of how we direct the execution of our code. They allow us to make decisions and repeat tasks as needed, making our programs dynamic and flexible. Without these, your code would just execute line by line without any decision-making or looping capability. First, we'll talk about why flow control statements are so important. They let us control the logic of our programs, determining what should happen and when. For example, do we execute this block of code or skip it? Do we repeat this task or stop after one iteration? These are the kinds of decisions flow control statements help us make. Next, we'll dive into the 3 main types of flow control statements in Python. We'll start with conditional statements. These include if, elif, and else, which are used to run specific blocks of code based on conditions. For example, you can check if a user's input matches a certain value, and then take an action based on that. Conditional statements are one of the most fundamental tools for building logic into your programs. After that, we'll move on to looping statements. Python provides us with 2 main types of loops: the for loop and the while loop. Loops allow us to repeat a block of code multiple times. For instance, if you need to process a list of items, a loop will save you from writing repetitive code. We'll also cover nested loops, which are loops inside loops, and how to use them effectively without overcomplicating your code. Finally, we'll cover control statements. These include break, continue, and pass, which give you extra control over your loops. Want to stop a loop early? Use break. Want to skip just one iteration and move to the next? That's where continue comes in. And pass? Well, that's useful when you don't want to do anything, but need to have a placeholder in your code. By the end of this section, you'll understand how to use flow control statements to handle various conditions and repetitive tasks with ease. This is a game changer in programming because it gives you the flexibility to create efficient, dynamic, and responsive Python programs. Alright, now that we've wrapped up the basics, it's time to move into the intermediate section of our Python journey. This is where things get even more exciting. We're going to kick things off by diving into functions in Python. We'll begin by understanding what functional programming is and why it's so important. Functions are the backbone of this approach. They're like the building blocks of your code. The main idea here is to break down complex tasks into smaller, more manageable pieces, which makes your code cleaner, more reusable, and easier to understand. Think of functions as tools that help you organize your code better. Once we've got the idea behind functional programming, we'll move on to the syntax for defining functions in Python. Here you'll learn how to use the def keyword to create a function, how to give it a name, and how to call it when needed. This is where you'll see the real power of functions. They make your code so much more organized. Next, we'll dive into parameters and arguments. These are what allow us to make our functions dynamic. By passing inputs to a function, we can adapt it to handle different scenarios without rewriting the same code. As we go deeper, we'll explore the 5 types of argument passing mechanisms in Python. These include positional arguments, default arguments, keyword arguments, variable length arguments, and keyword variable length arguments. Mastering these will give you a complete understanding of how to create versatile and flexible functions that can handle almost any situation. By the end of this section, you'll not only understand how to define and use functions, but also how to create functions that can adapt to a variety of scenarios. Once we've covered everything about functions, we'll shift gears to understand the concept of local and global variables. In Python, every variable has a scope, which determines where it can be accessed in your code. Some variables are local, meaning they're confined to a specific part of your program, like inside a function. Others are global, meaning they can be accessed from anywhere in your code. We'll break this down step by step. First, we'll see why it's important to understand the difference between local and global variables. Then we'll learn how to declare and use them effectively. For example, you'll see how local variables help keep your functions clean and self-contained, while global variables allow you to share data across multiple parts of your program. Next, we move on to one of the most important topics in Python: modules. Modules are a powerful feature of Python that helps us organize our code into reusable units. Think of modules as prepackaged sets of tools or building blocks that make your coding life easier. Instead of writing everything from scratch, you can simply use or create modules to save time and keep your code clean and efficient. We'll start by understanding what modules are and why they're so important. A module is essentially a file that contains Python code. This code could include functions, classes, or variables that you can use in your program. The purpose of modules is to promote code reuse and simplify your workflow. After that, we'll learn how to import modules into our programs using the import keyword. This is how you access the functionality that modules provide. Whether you're using a built-in module like math or a custom one you've created yourself, importing is the key step to unlocking their potential. Now, modules in Python can be divided into two main types. First is predefined modules. These are the modules that come built into Python, like the OS module, random module, or datetime module. We'll explore how to use these modules, what kind of tools they offer, and how they can simplify your programming tasks. Then we have programmer-defined modules. These are the modules you create yourself. We'll learn how to write our own modules, save them as separate files, and then import them into other programs. This is a great way to organize your code and share it across multiple projects. While working with programmer-defined modules, we'll also explore different approaches for reusing them effectively. By the end of this section, you'll not only know how to use Python's predefined modules, but also how to create and manage your own, which is a crucial skill for larger projects. Now that we've covered modules, let's move on to the next essential concept in our Python roadmap: packages. We'll start by understanding what packages are and why they're so important in Python. A package is essentially a directory that contains one or more modules, and it usually includes a special file called __in it __.py that lets Python recognize it as a package. The purpose of packages is to make your codebase cleaner and more scalable. Next, we'll dive into how to create your own packages. This is a key skill for organizing your projects. You'll learn step by step how to group related modules into a package, how to set up the package structure, and how to use it in your programs. Finally, we'll explore different approaches for reusing packages effectively. You'll see how to import specific modules from a package, how to use sub-packages, and how to manage package dependencies. By mastering these techniques, you'll be able to build robust and reusable Python projects with ease. After learning about packages, we'll move on to our next topic, that is, generators in Python. So, what exactly is a generator? A generator is a special type of function in Python that produces values one at a time instead of returning them all at once. This is incredibly useful when working with large data sets or when you want to optimize memory usage in your programs. We'll start by understanding what a generator function is and the role of the yield keyword. Unlike regular functions that use return, a generator uses yield to pause and resume its state, allowing you to produce a sequence of values over time. Once we've got the basics down, we'll dive into real-world scenarios and use cases where generators shine. For example, they're great for processing large files, streaming data, or building infinite sequences without overwhelming your system's memory. And now, we move to another critical section of our Python learning journey: the exception handling. Exception handling is all about managing errors that might occur while your program is running. Errors are inevitable, but Python gives us powerful tools to handle them gracefully. By using these tools, we can ensure our programs keep running smoothly even when unexpected issues arise. First, we'll learn what exception handling means in Python and why it's so important. Errors can happen for many reasons: a typo in your code, incorrect user input, or issues accessing external resources. Exception handling lets us address these issues without crashing our program. Before we dive into how to handle exceptions, we'll take a look at the different types of errors that can occur in our Python programming. These include compile time errors, like syntax mistakes that prevent your code from running; logical errors, where the program runs but doesn't behave as expected; runtime errors, which occur while the program is running, like trying to divide by zero or accessing a missing file. Understanding these errors is crucial because they help us decide how to handle each situation appropriately. Next, we'll explore the types of exceptions in Python. We'll begin with predefined exceptions. These are built into Python, like index error, value error, and key error. Then we'll learn about programmer-defined exceptions, where you can create your own custom exceptions to handle specific cases in your program. After that, we'll focus on the 5 key exception handling keywords in Python. These are try, except, else, finally, and at last the raise keyword. We'll understand how each of these works, and by the end of this section, you'll know how to combine them to write robust, error-resistant programs. Finally, we'll learn the syntax for exception handling and practice applying it to real-world examples. This is a vital skill for any programmer, because no matter how good your code is, handling errors effectively is what sets great programs apart from good ones. After learning about exception handling, we'll now dive into an essential and practical topic: file handling in Python. We'll start by understanding the purpose of file handling and why we need it. Think about it. Files allow us to store information that persists even after a program finishes running. This is how you save things like logs, configurations, or even user data that can be accessed later. Next, we'll explore the basic operations you can perform on files. This includes reading data from files and writing new data into them. You'll see how Python's straightforward methods let you open a file, extract its contents, or add new information to it with minimal effort. After getting familiar with file operations, we'll discuss file opening modes. Python provides 7 different modes for opening files, each tailored to a specific purpose. We'll cover all 7 modes in detail, showing you how and when to use each one, so you'll be fully equipped to handle files in any scenario. By the end of this section, you'll have a solid understanding of file handling in Python. This skill is incredibly useful, whether you're building applications that process user data, creating logs for debugging, or working with datasets in real-world projects. Now we move to one of the most critical and advanced sections of our Python roadmap: object-oriented programming. This part is by far one of the most important areas in learning Python, and it will require more time and focus compared to the other topics we've covered so far. With the help of object-oriented programming, we'll gain the ability to create our own classes in Python, giving us a powerful way to structure and organize our code. We'll start by understanding the meaning of object-oriented programming and why it's so crucial for writing efficient, scalable, and reusable code. Object-oriented programming is all about representing the real-world entities as objects in your programs. It's a way of thinking and organizing your code that makes it easier to manage, especially as your projects grow in size and complexity. Once we've got the basics of object-oriented programming, we'll dive into the concept of classes. Classes are the blueprint for creating objects in Python. We'll learn what classes are, how to define them, and explore their 2 main components, that is, attributes and methods. Next, we'll focus on constructors. In Python, constructors are special methods used to initialize the attributes of a class when an object is created. These are written using double underscore in it, double underscore. We'll explore the purpose of constructors, how they work, and the parameters they can take. One key parameter is the self, and we'll spend time understanding what the self means and why it's essential for working with objects. From there, we'll move on to instance methods and magic methods. Magic methods, also known as dunder methods, add special functionality to classes. We'll cover some of the most commonly used magic methods and their practical applications. After this, we'll dive deep into the 4 pillars of object-oriented programming. These are the fundamental principles that make object-oriented programming so powerful. These pillars are encapsulation, inheritance, polymorphism, and abstraction. Now that we've covered the core and advanced concepts in Python, we'll now move to database connectivity in Python. In almost every application, you'll need to store, retrieve, and manage data. This is where database connectivity becomes essential. Python makes it easy to work with databases, whether it's a lightweight database like SQLite or more complex systems like MySQL or PostgreSQL. We'll start by learning how to use Python's built-in SQLite 3 module to connect to a database. With SQLite, you can create, read, and update databases directly from your Python code without needing an external server. It's perfect for small to medium-scale projects. By the end of this section, You'll understand how to connect to databases and perform operations like creating tables, inserting data, and fetching records. Use ORM to write cleaner, more maintainable database code. Mastering database connectivity is crucial if you're planning to work on back-end development or build applications that rely on data storage. All right, we've come to the end of our Python roadmap. Let's quickly recap what we've covered. We started with the basics, learning about variables, data types, operators, and flow control statements. These form the foundation of any Python program. Then we moved on to intermediate concepts like functions, modules, and packages, which helped us understand how to organize and reuse our code efficiently. From there, we tackled advanced topics like object-oriented programming, exception handling, and file handling. These are essential for building more complex and real-world applications. We also explored additional topics like generators, database connectivity, that make Python so versatile. By following this roadmap, you'll not only gain a solid understanding of Python, but also develop the skills needed to apply it to real-world projects, whether it's data analysis, web development, machine learning, or automation. The key now is practice. Coding is like any other skill. The more you practice, the better you'll get. Build small projects, explore different libraries, and don't be afraid to make mistakes. That's how you learn and grow as a programmer. I hope this roadmap gives you a clear path forward in your Python journey. If you found this guide helpful, don't forget to like this video, subscribe to the channel, and share it with others who are learning Python. Let me know in the comments which topic you're most excited to dive into, or if there's anything you'd like me to cover in more detail.